We've already seen that soil is a particulate material, and one of the really interesting features of particulate materials is the voids that are between the particles. Now, depending on where the soil is, it can be either filled with air or with water, or a mixture of both. Now, in this video, I want to show you how important water pressure is in determining the behaviour of the soil. In my experience, major disasters can take place if the geotechnical engineer does not understand the importance of water pressure. For example, the Aberfan disaster in 1966, where water pressures were allowed to build up in a man-made soil on the hillside above the village of Aberfan. Eventually, the soil mass slid down the hillside as a slurry, killing 116 children and 28 adults. Now, in this demonstration, I want to show how important the water pressure is at the contact points between two particles. Now, I've got two particles here. You're going to have to bear with me, but one particle is this melamine board, if you can imagine that, and the other particle is a beaker, and here it is, and this beaker is full of water. And we place this beaker full of water on that surface, and you'll see that it is stable. Shearing resistance between the cup and the board is great enough to stop the cup from sliding downwards. Now let's look at an identical beaker. Here we are. We place it on that slope and we'll fill it with water. And we'll observe what happens. We'll see that that slides. We'll do it again. Now, why is that? Why should one beaker be stable and the other not? And the answer is that this beaker has a hole in the bottom. Now, the implications of that are that the water seeps through that hole, and the head of water generates a pressure between the beaker and the wet surface. The pressure that builds up causes the force between the beaker and the surface to reduce. Now, we know from the laws of physics that if you reduce the contact force between two frictional surfaces, you reduce the shearing resistance. And that is exactly what happens here. So we see from this demonstration how a build-up of water pressure between two particles can reduce the shearing resistance between those two particles. Many of you will have carried out experiments building sandcastles on beaches, and you will understand some of the things that can happen to them under various conditions. We're going to build 3 sandcastles. The first one is using dry sand. And we see it forms a cone here. The next one is with damp sand. Now here's another one which is also from damp sand. But what happens when the tide comes in? So let's see what happens. You see, this lovely, stable sandcastle has just slumped. Now, this effect and this effect we've covered already. Here we've just got the sand grains under their own weight, acting frictionally. Here, we've seen how water coming in below can reduce the forces between the particles, therefore reduce the shearing resistance, and the sandcastle slumps. Why is this one so stable? And to understand that, we need to introduce a new concept, which is surface tension. Between each grain of sand, there is a little blob of water, and the surface tension pulls the two grains together and generates forces between them, and that increases their shear strength. And that is why this performs so well. So in summary, we have seen that water pressure in the voids of a soil reduces its shear strength, whereas in a damp soil, the surface tension in the water between the grains increases the forces between them and increases the shear strength.